Good afternoon, welcome to your science review with Mr. Blades. Now we're going to continue our discussion with a parallel circuit. You can tell it's a parallel circuit because the electricity has more than one path down which to flow. Okay, so let's get started. Now we see we're connected to a 20-volt battery again, so I'm going to go ahead and write that down in my total voltage. And if we remember our rules regarding circuits, we remember that in a parallel circuit, the voltage is the same everywhere. So we can go ahead and write 20 volts in for all of these. Okay? Now you can see that my problem statement has also given me my resistances. And we're going to go ahead and calculate this two different ways. To check our math, also to demonstrate the rules and how they play out. So we remember from class that our table shows us which equations we can actually solve for right now because of how many unknowns we have. Right now we have two unknowns in the total column row, and we only have one in the R1, R2, and R3 rows. So let's go ahead and just start there and see if we can work it out that way. This is different than I normally do in class. So if we take Ohm's law, V equals IR, and divide both sides by R, we can rearrange this equation so that we are solving for I, which is V over R. So let's go ahead and use that. Now I1 is going to be equal to V1 over R1, or 20 divided by 15. That gives us 1.33. Okay. I2, likewise, is V2 over R2, or 20 divided by 10. And that's just going to give us 2. And then lastly, I3 is V3 over R3, or 20 divided by 6. And that is 20 divided by 6, or 3.33. Okay? Now if we add all these together, because remember all of our electricity goes in and it gets split here, here, and here, and then all of them recombine here, here, and here, so we can add all these up. So 1.33 plus 2 plus 3.33 gives us 6.66 amps of electricity. Now let's go ahead and use our Ohm's law to solve for the total resistance in the system. Again, V equals IR, but if I divide both sides by I can rearrange this so it gives me R. R equals V divided by I, or 20 divided by 6.66, or R of our total of exactly 3. Okay. Now, let's go ahead and use the total resistance equation that we're used to using to see if our math checks out. Okay. Our parallel resistance equation is equal to 1 over the total R is equal to 1 over R1 plus 1 over R2 plus 1 over R3, or 1 over 15 plus 1 over 10 plus 1 over 6. Let's go ahead and add that up on my calculator. And that gives us 0.33, or 1/3. Now, if we take the reciprocal of both sides to solve for R total, we end up with R total is equal to 3. And that agrees with what we saw. Okay? So I've just shown you two different ways to calculate the results for a parallel circuit. I hope this was helpful, and I'll see you in class.